Intel Arrow Lake has launched, and I've got the Z890 Steel Legend Wi-Fi motherboard that is actually a pretty good choice for Linux. This is one of the better choices for Linux if you're content with a 2.5 gigabit LAN. If you want a 5 gigabit LAN, there are options. Now, I've already unboxed this video and we've taken a look at the ports. If you missed that live stream, we took a look at the Taichi, the Nova, and the Steel Legend. And the Steel Legend is, as always, at kind of a unique place. It doesn't have all the bells and whistles of the Taichi, or really even the Nova. Actually, the Nova might have more bells and whistles than the Taichi, depending on what you're looking for. But the Steel Legend gets it done and will let you run even up to a Core Ultra 9 285K at full tilt. Now, I know some of the launch reviews of the Core Ultra 9 285K may have been disappointing for gamers, but for multi-core performance, compile workloads, and like actually doing work on something that's a workstation-ish, but you know what I mean when I say workstation. We're not talking quad channel memory or something really high-end. But this will get it done because it's 24 cores and 24 threads. Let's take a closer look. So the board layout here is pretty interesting. You've got your blazing M.2 at the top. Blazing in ASRock vernacular means PCIe Gen 5. And this motherboard has one blazing Gen 5, and you've got 3 PCIe Gen 4. But Arrow Lake adds more PCIe lanes and moves the storage lanes up to PCIe Gen 5. And that means that SSDs like our 4TB T705 run like greased lightning. This thing can do 15 gigabytes per second. The blazing M.2 heatsink is also sufficient for the T705, which does require active cooling, or at least a large heatsink and enough airflow. Because this one is not smothered by the GPU because of this layout, it's a good choice. Let's just take a closer look at the rear I/O. We got our antenna ports. That's for our Wi-Fi 7 solution, our BIOS flashback button, so that if there are future CPUs that come out, you can flash the BIOS. Or sometimes if your computer won't post, it's gotten into a weird state, and reflashing the BIOS will help. Your HDMI out. You got USB 3.2 Gen 2, 2 of those, and then 2 Thunderbolt 4 Type-C ports. And yes, this is fully supported on Linux, and as long as your iGPU is enabled, those Thunderbolt 4 ports can do display out. So you can use them with USB-C to DisplayPort cables, or if you have a USB-C or Thunderbolt display, that'll work fine with those. Again, coming from the integrated GPU. You've also got a 2.5 gig LAN that I mentioned, 2 USB 2 ports, and you've got 2 USB 3.2 Gen 1 ports on the top and 2 USB 3.2 Gen 1 ports on the bottom. Now, these Lightning ports have a different power delivery system, which is a kind of a special sauce thing that ASRock does, but in doing work on the KVMs, the power delivery from those ports is actually better. It also has analog microphone and speaker out, as well as optical SPDIF. The motherboard also features 4 SATA 3 ports, a number of 4-pin fan headers. It does have RGB headers, addressable RGB, as well as 50/50 headers, 20K black caps. It's a pretty well-built motherboard for what it is, and the Wi-Fi solution is the Intel 802.11be Wi-Fi 7, so it's the higher quality. I mean, ASRock didn't cheap out on the Wi-Fi. I like the Intel solution for Linux especially, a little better than most of the other ones. It's an 18 +1+1+1+1 power phase delivery system, and again, even with the Core Ultra 9 285K, perfectly reasonable, perfectly stable. Now, you may be wondering, Arrow Lake, error correcting UDIMMs. Good news, a bit of a mixed bag, good news, bad news. Intel has not fused off the capability of ECC. DMI decode-T memory correctly detected the memory at 80 bits wide, but there is no EDAC driver. Now, Arrow Lake S got an EDAC driver for kernel 6.11, and I tried the patch for that, but it's not working yet. So I'm not sure if that's a BIOS disable for ECC, or if Intel is going to do like they did with prior generation parts, requiring workstation chipsets in order to do that. The 14900K and the 13900K worked fine with ECC UDIMMs, but it required a motherboard that was based on the W680 chipset. We don't have a W680 chipset equivalent for this socket. I really hoped that Intel would not play games with whether or not you get error correct. Like, just leave it up to the board makers. If ASRock wants to say, yes, our Steel Legend does error correction, then you get the capability for ECC UDIMMs. Man, ECC, CU DIMMs, good lord, that would be that would be something special. And ASRock Steel Legend for AM5, the competing platform, guess what? Works fine. And it works fantastically well as of Agiza 1.2.0.0 or newer on the AM5 platform. It took a little while to get fully baked ECC UDIM support on AM5, but we're there now in 2024, and so that's welcome. Let's take a closer look at my actual setup. Fastest DDR5 training time ever, good lord. For 8600, I mean, come on. That's one of the things that I'm, as the Arrow Lake platform sinks in a little bit, even if you're a gamer and you're disappointed by the gaming performance, which basically is par. Like, let's be clear, it's not really dramatically slower than the 14900K, mostly, but it's not really faster either for gaming type workloads. Multicore, a little better, way less power for multicore. Gaming, slightly less power, not dramatically less power, but somewhat less power. But for multicore, yes, less power, like north of 100 watts less power in full multi-core workloads. But the quality of life on the overall platform is improved pretty significantly, and Intel developers have contributed patches for the platform to make Arrow Lake a little better. From a virtualization platform standpoint, it is a huge difference. So like running my Proxmox test, where I just set up some virtual machines and clone them and move them around, these E-cores are a completely different critter than the E-cores on prior generations. These E-cores are phenomenally faster, even though they're sort of clock limited in that like 3.7 to 4 gigahertz range if you want to get into overclocking. And they're probably faster than 11th gen Intel. It's close. It's really close. It's so absurd that if you disable the P-cores and you just run E-cores entirely, older games seem to actually run better. But, I'm talking like Borderlands 3. Somewhat, in some conditions. But this is a Linux review. Let's not talk about that. Let's talk about Linux. So when you're talking Proxmox and you're juggling virtual machines and everything else, the Ultra 9, 8 P cores, 16 efficiency cores, and the Ultra 5, 6 performance cores, 8 efficiency cores, that is a pretty interesting platform for virtualization. Much more interesting than prior generations. This thing is more power efficient than Intel's mobile CPUs in a fully unlocked configuration before, which says a lot. And also the fact that the geometry of the P and E cores have changed mean that things like Proxmox and KVM work a little better. There are some things that I think could be done better in terms of scheduling and Linux kernel hints, but generally it's pretty good. And the core-to-core latency is also pretty good on this platform, even though it is a tile-based platform and all of that. And all of this is running on the Steel Legend Wi-Fi Z890, so I'm pleasantly surprised that there are no real major teething issues with Linux on this platform. So if you're on an ancient platform, something older than 12th gen, then yeah, this upgrade could make sense. If you can get a 12th or 13th or a 14th gen Intel part on fire sale, that might still be a better choice if you are cost conscious, even for like the Ultra 5. So good job ASRock on putting this together, and definitely good job AData on your XPG memory kit. The 8600 kit that I named before works really well on this platform. This is the dual 16 gig kit, so it's a little smaller, it's a little slower. I think also the memory latency will improve with BIOS updates and timing and that sort of thing, because I noticed if you disable the P cores and you run only E cores, you can get memory latencies of like 70 nanoseconds, whereas it's really hard to achieve 80 nanosecond memory latencies when you're working only with performance cores. So I'm not sure what that's about. Anyway, this has been a quick look at the Z890 Steel Legend Wi-Fi. It's good for Linux. I'm Wendell, I'm signing out. You can find me in the Level 1 forums if you want to see me do anything else or test it or run a specific workload or just, talk Arrow Lake in general. But yeah, alright, signing out, I'll see you there.